Hey guys, welcome to a new video series. So in this series, we are talking about Year 8 algebra. And as I've said before, a lot of when we do these video series in later years, a lot of the stuff we've done that you cover in, for example, Year 8 algebra, you did in Year 7. So in these series, I'm only doing the brand new things you'll be encountering in Year 8 algebra. So in doing this, I'm assuming when we start that you've done adding like terms, multiplying, dividing algebraic expressions, as well as expanding. Because today we are going straight into the idea of factorizing algebraic expressions. So the reason I mentioned that you should understand some of the building blocks to get to this that you've done in Year 7 is because one of the topics from Year 7 actually goes hand in hand with what we're going to be doing today. Because to understand about factorization, we need to first recall what we mean by expansion. So factorization is actually going to tell us a lot about expansion and vice versa. So we need to just quickly revise this idea of expanding the brackets, right? So what this thing means here is essentially we're taking three lots of 2x plus 5. Now, I'm going to do this the longer way just to give you guys a good solid revision of what we mean by expanding the brackets. So this thing here is like saying we have three lots of 2x plus 5. So we have 2x plus 5 plus 2x plus 5 plus 2x plus 5. Because multiplication is just a shorthand way of adding. As we said in previous videos, multiplication is just an abbreviation for addition. It's a shorter way to do addition. Now, what we're going to do here is we see that we have a few like terms, 2x plus 2x plus 2x. Now, if you guys remember with adding, the order doesn't matter in which we do this. So 2x plus 2x plus 2x gives me 6x. And if I add all the 5s together, that gives me 15. And that's how we would expand something. And you guys may remember as well, I did this thing with the arrows. So we're multiplying this first term by 3, then we're multiplying this next term by 3. So to understand factorization, I want to write this thing. Let's write 6x plus 15 down here. So we have 6x plus 15. And to get from here down to here, this was the idea of expanding. Now, before we talk about factorizing, I want to just get you guys thinking about something in particular. How does this 3 relate to both 6x and 15? There is something that both of these numbers have in common with 3. Well, may not be immediately obvious, but 3 actually goes in to both 6x and 15. Now, how many times does 3 go into 15? Well, it goes into 15 5 times. So think about it. To get from up here to down here, we expanded, we multiplied. Now think of what we're doing to get back to relate my outside thing with my outside factor of 3 with 6x and 15. Well, to get back to this 5, we were doing a type of division, sort of, right? We were saying, well, how many times does 3 go into 15? Goes into it 5 times, right? And division is the opposite of multiplication. We can get 15 from multiplying 3 and 5, but we can also get 5 from saying, well, how many times does 3 go into 15? Let's consider this 2x as well. And look, I'm not going into any theory just yet. This is just something for you guys to think about which will hopefully give you the intuition as to what factorizing actually tells us in the first place. Now, how does this number 3 relate to my 6x? Well, we said it goes into 6x. How many times does 3 go into 6x? Or in other words, what would be 6x divided by 3? Well, to split 6x up into three equal parts, I would have a 2x, I would have a 2x, and I would have a 2x. 2x is what we get when we split up 6x into 3 even parts. And look at that, 2x is the other term inside my bracket. So when we go from top to bottom here, from 3 outside of 2x plus 5 into 6x plus 15, we are expanding. And the process of what we're going to drill and talk about today is, the idea of factorizing. And this should be a hint, right? It's in the word. Factorizing. We've noticed here that 3 was a common factor in both 6x and 15. In other words, 3 is the highest common factor. So today we are dealing with the highest common factor, HCF, in order to factorize expressions. We're factorizing algebraic expressions. Now, let's look at what we mean by that. So, if I have, for example, let's look at, for example, let's do one example here, and we'll do a few more that are trickier. So, I'm going to try to get you guys to think about how you would factorize 12a plus 18. Now, to factorize is to find a common factor in both of these things. We are going in reverse. Expanding gets us from up here, from this first expression, down to the next. Factorizing gets us from an expanded form back into a bracket form here. These are opposite operations in the same way multiplication and division are opposites. This is the main idea that we're talking about today. This idea of the opposite nature of factorizing and expanding. And understanding this is going to get you a long way in terms of factorizing expressions in this course. So, in order to factorize, we want to find the highest common factor of 12a and 18. We want to find a number that goes into both 12a and 18. In fact, we want the highest possible number that goes into these. So we want to think, well, what's the biggest number that goes into 12 and 18? Now, you can take some time, you can pause the video, have a go at it on your own, but I know from my times tables that 6 goes into both 12 and 18. So 6 then will also go into 12a and 18. So I can say here, the highest common factor is 6. Now I want to think, how many times does 6 go into 12a? Well, it goes into it 2a times. 6 goes into 12 2 times, and the a just stays there, right? Because we don't know what it is. So we leave it there. So in other words, if we were to split up 12a into 6 equal parts, we would get 2a plus 2a plus 2a plus 2a plus 6 times. We would get 6 2a's adding together to give me 12a. So that is going to be how many times 6 goes into 12. So into 12a, sorry. So 6 goes into 12a 2a times. Now, how many times does 6 go into 18? Well, we can just find that by dividing 18 by 6. So we can say 6 goes into 18 3 times. So factorization is to expansion, kind of like what division is to multiplication. So I want to find out what number goes into both of these and what was the kind of bracket form that I had before I expanded to get to this thing here. So my highest common factor is 6. So that is the number that's going to go outside my brackets. So 6 is going to be outside of, and these things I found here, 2a and 3, are what go inside my brackets. So I had positive 2a and positive 3. So this thing here that I have is the factorized form of this expression here. In the same way that here, going from the bottom to the top here, that's what the process of factorizing, what factorization is. And the brilliant thing about this, guys, is that you can check if this works. How can you check that? Well, you can check it by re-expanding. And if you get this thing here, 12a plus 18, you've done it right. A good analogy for this is, I don't know if you guys did this, but when I was younger, me and my friends would sometimes, as a joke, mess around on Google Translate, right? So we would put something, translate it from like English to Portuguese, and then we'd copy and paste the Portuguese thing and paste it in, translate it back to English. And sometimes it would give you like a completely different thing. So that is not what we want here, right? We want to return back to know that we factorize correctly. We want to, when we re-expand 6 outside of 2a plus 3, we want to get back this exact thing. We don't want this like goofy other thing with like different numbers. We want the exact same thing back. That's how we know we factorize correctly. So what we're going to do here is we are going to check by expanding. So we want to expand this thing here. And what we do here is we just multiply 6 by both terms in the brackets. So we have 6 times 2a gives me 12a, and 6 times 3 gives me 18. Let's just check. Well, that is correct. We have factorized correctly because these are opposite operations. We can go back and forth here. So we can, once we have an expanded thing, once we factorize it, we can check that it's right then by going back the other way. Okay, let's do one more example and we'll wrap up for today. Let's look at what happens when we have let's go 10xy minus 20y. Now to start off, we want to find the highest common factor. We want to find the highest number or expression that goes into 10xy and 20y. Now, one of these should hopefully be obvious. I know that 10 goes into both 10 and 20. So I'm going to write that down is 10. The 10 goes into both of these. I know that for sure because it goes into 10 and 20 and negative 20, I should say. But also notice that we have a y term in both of these as well. So y goes into these two terms as well. So the highest common factor is actually going to be 10y. We are now considering the algebraic term as well. Because we don't know what y is. We know it goes into both of them. We know 10 goes into both of them. So the highest common factor here is 10y. So when I get this, I want to say, okay, well, how many times does 10y go into each term? So 10y goes into 10xy. It goes into this. Well, what's the thing remaining? Well, I have my 10y, so what's remaining is my x. So 10y goes into 10xy x times. Or in other words, when I divide 10xy by 10y, my 10s will cancel out, my y's will cancel out, and I'm left with x here. So I can say 10y goes into 10xy x times. And now I want to find out how many times 10y goes into negative 20y. Okay, well, I have a y, so these are going to cancel out. So I only need to find out now, well, how many times does 10 go into negative 20? Well, it goes into it negative 2 times. So now I have my inside the brackets terms. This is what is going to go in my brackets when I pull out my highest common factor of 10y. So check this out. When we pull 10y outside of my brackets, well, I'm trying to see what multiplied by 10y to give me 10xy. We already figured that out. That is x. And what multiplied by 10y to give me negative 20y? Well, that was negative 2. This is my factorized form. Now, once again, I can check this because I'm doing a multiplication here. So to expand, I can check if my factorization is correct by just expanding this. And I should get back my original expression in the question. So 10y times x gives me 10yx or 10xy. Doesn't really matter which order. And 10y times minus 2, now we have to be careful of the negative here, guys. I have a positive number, 10y, multiplying by a negative number, so I'm going to get a negative number back. So 10y times negative 2 gives me negative 20y. And I can check this with my original thing. Boom, it's exactly the same. So I have done my factorization correct. So just to summarize, when we want to factorize something, we are doing the opposite of expanding. And what we want to do is we first find the highest common factor, the biggest number that goes into both of my terms here. And then I just want to see how many times it went into each of these terms. That's what this little red writing here is. And once I find how many times, these two things, x and negative 2, end up being my terms in the brackets. And 10y is what gets pulled out. That's the highest common factor. And we can check this by re-expanding. And we can always do that. We can always check by re-expanding. And if we get my original expression back, we have done it right. Thank you so much for joining me, guys. I'll see you in the next video.